Welcome back to the master class. We've come a long way from thermal boiling to the fast atom bullets of fab, but today we reach the true frontier of gentle force. Imagine you are tasked with moving a fragile, priceless crystal glass. You could kick it. That's essentially fab. Or, you could have 1,000 people gently surround it and lift it in unison. In the high-end lab, we call this massive cluster impact, MCI. Today, we master the art of the collective hug. Actually, the difference between an operator and a strategist is understanding energy density. We are moving from point impacts to surface impacts. Today, we are going to learn how to use a wrecking ball made of 1 million molecules to lift 17,000 Dalton proteins into the air, completely intact. It's a transition that turns a shattered result into a clean discovery. To conquer this level of precision, we navigate 4 strategic sectors. Sector A, building the wrecking ball, how we generate clusters weighing 100 million units. Sector B, the physics of gentle violence, understanding energy per nucleon. Sector C, microscopic judo, the mechanics of collective energy transfer. And Sector D, strategic ROI, why seeing a naked protein is worth the effort. How do we create a projectile made of 1 million molecules? We use electrohydrodynamic ionization. Specialists' insight. We aren't just creating ions, we are creating droplets that are supercharged. These massive clusters carry an average of 200 electron charges. It's not a bullet. It's an industrial-scale projectile designed to overwhelm the surface with weight. Have you ever wondered why MCI is so gentle despite using 20 kilovolts of acceleration? It's the math of distribution. In fab, 10 keV is concentrated on one single xenon atom. That's a high-density strike. But in MCI, that same energy is spread across 1 million molecules. Mentor's tip, the energy per nucleon, is less than 1 electron volt, enough to shake the surface, but not break a bond. When these clusters hit, they flatten out like a liquid disk. Think of it like a beanbag hitting the floor. It spreads its momentum over a wide area. Instead of a localized explosion that shatters the analyte, you get a clean, lateral shockwave. This shockwave is what nudges our large biomolecules off the surface. We are using the weight of the crowd to exit the building. I like to think of MCI as microscopic judo. We are using the massive weight and inertia of the cluster to our advantage. As the cluster compresses, the resulting upward momentum scoops the intact analyte into the gas phase. It even provides a temporary solvation shell during the launch, shielding the protein from the cold vacuum until it's safely in the analyzer. As a specialist, you monitor the signal-to-noise of purity. In fab, you see a forest of fragments surrounding your peak, the chemical noise of radiation damage. In MCI, that forest disappears. Actually, you might see fewer ions overall, but the ones you see are the intact truth. We are capturing proteins with a yield that allows for precise molecular weight determination. We choose MCI when the sample is too fragile for even fab. It excels in synthetic polymers and large proteins. Consultant's secret. This is the tool of choice for structural forensic architecture. When you need to prove your polymer hasn't degraded during manufacturing, MCI gives you the audit-proof data that stands up under scrutiny. It is your insurance policy for purity. Have you ever tried to move a grand piano by yourself? You can't do it without scratching the floor. But with 10 movers, it looks easy. That is the essence of MCI. We've stopped trying to be the lone hero atom and started using the team effort of the cluster. It removes the risk of molecular heatstroke and allows physics to be your partner, not your enemy. We work smarter, not harder. Summary. The strength of the crowd. We've mastered 20 kilovolts acceleration, the logic of low energy per nucleon, and the judo-style lift of collective transfer. You now understand why weight is a lubricant for recovery. Remember the specialist mantra. Strength in numbers isn't just a cliché. You are now equipped to handle molecular titans with absolute confidence. Silence the doubt in your data. We've mastered the kinetic impact of atoms and clusters. But what if we used pure light instead of matter? Join me in our next unit, Module 6-6, Laser Desorption and MALDI, where we learn how a silent burst of photons can launch macromolecules to the stars. We are moving from kinetic impact to photonic acceleration. I'll see you at the laser source. Any final questions on the wrecking ball?